Hello student, last class we have discussed what is magnetic field, how magnetic field develop if there is a current carrying conductor, and what is snow rule, what is Ampere's rule, what is the right hand thumb rule, how can we find direction of magnetic field. Last class we have discussed. Clear? Now in this class we have discussed two important aspect to calculation of magnetic field. First aspect, we have to calculate magnetic field, and second aspect, we have to calculate force due to magnetic field. Clear? So how can we find magnetic field? By using Biot Savart law. So what is Biot Savart law? Suppose there is a current carrying conductor and I is the current flowing through the conductor from A to B. Clear? There is a point P where we have to calculate magnetic field, and there is a point P which is at a distance, and it's R vector which is at a distance R due to this element and this element length, and it's a dl length. Clear? And this is dl element or length element, and this is the position vector at point P where we have to find magnetic field, and this angle is theta. What is theta? Theta is angle between dl vector and r vector. Clear? So according to Biot Savart law, if there is a small element dl, due to this small element and current flowing through the element I, then due to this small element, the magnetic field strength at point P, that is dV, that is small magnetic field, and this small magnetic field and this small magnetic field which is directly proportional to I, that means current flowing through the conductor. If current flowing through the conductor is maximum, then magnetic field will be maximum. That means if we increase the current through the conductor, then magnetic field also increase. First point. Second point, dB is directly proportional to dl, the length element, that is dl. If length of the conductor increase, then magnetic field also increase according to Biot Savart law. Clear? Next point, it is dB, magnetic field strength is directly proportional to sin theta. Sin of angle between two vector. What is theta? Theta is angle between dl vector and r vector. Clear? Next point, the magnetic field is inversely proportional to 1 by r square. What is r? Distance between length element and the point P where we have to find magnetic field according to Biot Savart law. Clear? This is equation 1, equation 2, equation 3 and equation 4. On combining these equations, we can write magnetic field at point P, that is dB, due to small element dl, and here dB is directly proportional to, if you combine these four equations, we can write I dl sin theta by r square. This is the mathematical expression of Biot Savart law. Clear? If we remove proportionality, then we can write, and this equation turn to be dB equal to one constant which is mu naught by 4 pi idl sin theta by r square. This expression is called Biot Savart law, and this is scalar form of Biot Savart law. Clear? So dB equal to mu naught by 4 pi ideal sin theta by r square. And this Biot Savart law only valid for small element, small length element. It cannot valid for total or maximum length or total length. Clear? If you find the magnetic field due to total length, that means A to B, so we have to integrate the above equation, that is total magnetic field from A to B, integrate the total magnetic field B, which is equal to mu naught by 4 pi constant quantity. So mu naught by 4 pi integrate A to B IDL sin theta by r square. Because Biot Savart law only valid for small element, first we have to find magnetic field for this small element, then we have to find magnetic field for this small element, then we have to find magnetic field for this small element at this point. Clear? Because the direction of magnetic field due to small element are in one direction. Clear? Because next later we will discuss the direction of magnetic field, then we will clear what the direction due to this element, due to this element, due to this element at this point P. So this is scalar form and this is total magnetic field due to the element due to the total current carrying conductor A to B. So this is important relation where mu naught by 4 pi. What is mu naught by 4 pi? Mu naught by 4 pi is constant quantity where mu naught by 4 pi is constant quantity and its value 10 to the power minus 7 Tesla meter per ampere. Clear? Mu naught by 4 pi 10 to the power minus 7 Tesla meter per ampere. So we can write what is mu naught. Mu naught is called absolute permeability in free space. Clear? And the value of mu naught we can write. The value of mu naught we can write, since mu naught by 4 pi equal to 10 to the power minus 7 Tesla meter per ampere, then the value of mu naught, that is mu naught equal to 4 pi into 10 to the power minus 7 Tesla meter per ampere. Clear? This is the value of absolute permeability in free space, 4 pi into 10 to the power minus 7 Tesla meter per ampere. You have to remember this value and the SI unit of absolute permeability. Clear? Now next we will go for the vector form of Biot Savart law. Vector form of Biot Savart. So MEC, magnetic electron current. So vector form of Biot Savart law. Vector form of Biot Savart law. So what is vector form of Biot Savart law? As we already know, the magnetic field due to small element, small current carrying element, dV equal to mu naught by 4 pi IDL sin theta by r square. Clear? Or we can write this relation, that is mu naught by 4 pi into IDL sin theta by r square. Now multiply 1r and divide 1r. Clear? If we multiply this, then the above equation turn to be mu naught by 4 pi into IDL r sin theta divided by r. Clear? Or the above equation can be written in vector form, that is mu naught by 4 pi into I. This constant quantity, so you can take it out. Then dr sin theta. Dr sin theta. What is dr sin theta? That means A cross B equal to AB sin theta. So this is the cross product. cross product of dl vector cross r vector divided by this cube of magnitude, so we can write r vector magnitude cube, and then this relation will be d vector. This is the vector form of Biot Savart law. Clear? dv vector equal to mu naught by 4 pi I dl cross r vector divided by r cube. Clear? This is the vector form of Biot Savart law. Vector form of Biot Savart law. Clear? And this vector sign indicates that magnetic field is a vector quantity, and this is the magnitude, so we can find the direction of this magnetic field. Clear? So how can we find the direction of dv vector? That means the direction of magnetic field. So we have to use cross product of two vector. What is cross product of two vector? Suppose we have two vector, a vector cross b vector, and then we get another vector c vector, because the cross product of two vector which give a vector quantity, and the direction of c vector which is always perpendicular, the direction of c vector which is always perpendicular the plane containing a vector and b vector. Suppose this is a vector, the vector is a vector, and another one vector which is b vector, and angle between two vector theta. So this is plane, this is the plane containing a vector and b vector, but here we have to find the direction of c vector. So how can we find this direction? By using right hand thumb rule. First, place your palm, right palm on vector a, then come towards b, or call your finger towards b. Then a vector a cross b, a cross b, a cross b, then thumb indicate third vector. A cross b, then thumb indicate third vector which is perpendicular to the plane containing a, and this is plane, and third vector, the direction of third vector, this is the direction of third vector. Clear? So in this case we can write dot indicate the direction of vector c. So this is the direction of cross product of a cross b. Clear? Similarly, we have to find the direction of db, where two vector dl cross r vector. Now find the direction of magnetic field dv vector. Clear? This is the relation. So this element is dl. Clear? It's the direction of dl. Okay. First we have to know what is the direction of dl. dl means if this is the direction of current from A to B, then the length element also along the direction of current. So this is the direction of length element dl. Clear? Or idl vector also known as current element. This is current. Clear? So this is the direction of length element along the flow of current, and this is the direction of position vector. Clear? Is the direction of position vector where we have to find the magnetic field dB and angle between two vector theta. Clear? But look at this point. This is dl cross r vector. That means dl vector cross r vector. There is two vector, dl vector and r vector, and there is cross product of two vector. So then the resultant vector, that is dl vector cross r vector, which give the resultant vector, or which give the third vector, which is db vector. Like a vector cross b vector equal to c vector. So c vector here db vector, and the direction of c vector always perpendicular to plane containing a vector and b vector. Similarly, the plane containing dl vector and r vector, the direction of db vector which is perpendicular to plane containing dl vector and r vector. So this is plane, because this is dl vector and this is r vector. So this is plane of dl and r vector. So how can we find direction? By using right hand thumb rule. First place your palm write pan on dl vector, because first dl then r vector. So this is a dl vector. This is dl vector, dl vector. Now call your finger towards r vector. dl cross r, dl cross r. So dl cross r, the thumb indicate the direction of third vector. So the thumb indicate the direction of third vector, which is inward direction and perpendicular to this board. That means if we find the direction of magnetic field at point P, so in this point the direction of B, which is inward direction, we can represent cross, that is dB vector. Clear? So for this small element, the direction of dB, which is inward and perpendicular to this board, because the plane dB and this is r vector. Suppose another element, this element is another element dl element, and which situated at a distance r1 vector, and angle between two vector, that is theta. So what is the direction of magnetic field due to this element? Similarly, this is dl element, dl cross r vector. So dl cross r1 vector. So dl cross r1, which is inward direction. So due to all the small element of current carrying conductor, the total magnetic field, which is inward direction, so we can integrate it easily, because all the vector quantity in one direction. So the direction of magnetic field dB can be write direction of magnetic field the direction of magnetic field or dB vector, which is perpendicular to the plane containing dl vector and r vector, which is always perpendicular to the plane containing dl vector and r vector. In this case, that is perpendicular to both and inward direction. Perpendicular to both and inward direction. This is the direction of magnetic field. Clear? This is Biot Savart law, scalar form, vector form, and direction of magnetic field. Now we will start the application of Biot Savart law. So first application of Biot Savart law, that is called magnetic field at a point due to a long straight current carrying conductor. So if there is a long straight current carrying conductor and current flowing through the conductor I, and there is a point P which is at a distance d, and this distance is perpendicular distance d, where we have to find magnetic field, where we have to find net magnetic field at this point due to this current element or long straight conductor. Clear? So how can we find total magnetic field? We have Biot Savart law, and Biot Savart law only valid for small element, small current carrying length or small current carrying element. Suppose we have a small element, if this is long straight conductor, if it divided into small part or small length, this is small element, this is another small element, this is another small element. First we have to find the magnetic field for small element, then this small element, then this small element, and this small element, then we can add all of them to find total magnetic field. So first we have to find magnetic field for small element or small current carrying element. Suppose this is small element and this is the direction of current, and this element is dl. Clear? Which is, this point is O point and this point represent this point, that is point Q. This point Q point, clear? And this DL element or point Q, which is at a distance L from point O, and this DL element is very small, negligible distance. If you join the point P, then this point, clear? This point, and suppose this angle theta, this is distance D, and this angle theta. Because what is phi 1? Phi 1 means the end point angle from point P. This angle is phi 1, and this total angle is phi 2, or this total angle is phi 2. Clear? This total angle phi 2, but this angle is theta. So we have to find magnetic field due to this small element at point P. Let the magnetic field for this small element at point P, that is dB. Clear? So dB equal to, according to Biot Savart law, we can write mu naught by 4 pi I dl sine divided by r square. What is r? Suppose this distance, the distance between dl element and P point, that is r vector. That means this vector is r vector. And if this angle theta, then this angle 90 degree. So this angle will be 90 minus theta. That means this is the angle between dl element, this is length element, and this position vector or r vector, which make an angle 90 minus theta. So you can write here, that is ideal sine theta. So theta here 90 minus theta divided by distance between point Q and point P, that is r. So dB equal to mu naught by 4 pi ideal sine theta by r square, or we can write this above equation relation, that is mu naught by 4 pi into IDL sine 90 minus theta. We know sine 90 minus theta equal to cos theta divided by r square, and it is d. Clear? This is the magnetic field due to small element, and this is the magnitude only, but the direction of this magnetic field, we can use cross product, that is dl vector and r vector. So dl cross r, which is inward direction. Clear? This is magnetic field for this small element. But we have to find total magnetic field due to this current carrying conductor. So how can we find this magnetic field? There is this angle also changes, because if we take this point Q to point, if we coincide point Q with point O with Q, then theta will be 0. Then theta will be last point, this is conductor A and B. If we take point Q at point A, then theta will be phi 2. Clear? If we take this point Q at point B, then theta will be phi 1. So here theta is variable quantity, and dl also variable quantity, and r also variable quantity. There are 3 variable quantity which is difficult to integrate. First, we have to make them one variable quantity or one variable physical quantity. So how can we write? This is equation 1. Clear? Now we have to find dl, the length of dl element. We know this right angle triangle, there is one right angle triangle, this right angle triangle, this point P and this point O and this point Q, this angle 90 degree, this angle theta, and this R, this side L and this side D. Clear? So cos theta equal to, what is cos theta? Cos theta equal to, this is base, this is our perpendicular, and this is our hypotenuse. So from this right angle triangle OPQ, this angle 90 degree, this angle theta, and this angle 90 minus theta. So this is OQ, OP, and PQ. Clear? From this right angle OPQ, cos theta equal to, because here we have to find the value of R and value of DL. There is three variable quantity DL, cos theta, R square. So first we have to find R. R means from this right angle triangle OPQ, cos theta equal to B by H. B means base, so this is base and this is height and this is hypotenuse. So B by H cos theta equal to B. Base means D by hypotenuse equal to R. So you can write R equal to D by cos theta, and R equal to, if you take cos theta, then it will be sec theta. So R equal to D sec theta equation 2. Similarly, from this right angle triangle, that means from right angle triangle OPQ, and tan theta equal to P by B, perpendicular upon base. So L by D and L equal to D tan theta. Clear? If we integrate to this relation, then this relation turn to be with respect to any physical quantity, then DL, then L D tan theta. If we differentiate, then DL equal to, with respect to theta, then DL equal to D, the differentiation of tan theta equal to sec square theta, or you can write this is DL by D theta equal to D by D theta of D tan theta, D tan theta, that is equal to D tan theta by D theta, so D sec square theta. Then here D theta, so DL equal to this quantity multiply here, that is D theta equal to DL. So DL equal to D sec square theta into D theta equation 3. If we use now using equation 2 and equation 3 in equation 1, then the relation turn to be, that is dB equal to mu naught by 4 pi into IDL, I into DL. What is DL? DL, that is D sec square theta. So D sec square theta into D theta into cos theta. So this is cos theta divided by R square. This is R, D sec square theta. So D square sec square theta. Clear? Now solve this relation. We can write dB equal to, so dB equal to mu naught by 4 pi, 1D cancel, so I by D sec square theta cancel. Now remaining part cos theta into d theta, so cos theta into d theta. Clear? This is small, the magnetic field due to this small element, but we have to find net magnetic field at point B due to this current element from A to B. So how can we find? Because the direction of all the small element in one direction, which is inward, so can integrate it easily by using integration. So total magnetic field can be calculated by using integrating to the above relation with proper limit. Clear? Now we have to integrate the above relation. So the relation turn to be, then this is dB. So total magnetic field due to the element A to B, which is will be B. So net magnetic field at point P, that is B, equal to mu naught by 4 pi I by D, which is constant quantity. So you can write mu naught by 4 pi into I by D integration cos theta and d theta. Clear? Here theta is, if we take the point Q to A, then theta will be phi 2. Clear? If we take the point Q to point B, if we coincide point B with point Q, then the point Q, if the point Q which is coincide with B, then this angle will be phi 2. If this is reference line, then this angle we can write this angle which is minus phi 2, and above the angle which can write plus phi 2. So cos theta d theta can be write, it is minus phi 2 because this is reference line, and this is plus phi 1. We have to integrate minus phi 2 to plus phi 1. Clear? So B equal to mu naught by 4 pi I by D into cos theta d theta integration sin theta, because cos theta d theta integration which is sin theta, it is sin theta integration, lower limit minus phi 2 and upper limit phi 1. Now the above relation turn to be, the above relation can be write B equal to, magnetic field B equal to mu naught by 4 pi I by D. Now use the limit. First we have to use upper limit, then sin phi 1 minus sin of minus phi 2. Clear? But this sin function which is odd function, so we can write B equal to mu naught by 4 pi I by D sin phi 1 plus, this is odd function, so sin minus phi equal to minus sin phi, cos minus phi equal to cos phi. This is even function and this is odd function, so we can write minus, so we can write sin phi 2. This is the total magnetic field due to the current element, or due to the long state current carrying element and current flowing through I and from A to B, and here the total magnetic field B, it is B net. So B net equal to, or total magnetic field due to this current element at point P, B net equal to mu naught by 4 pi I by D sin phi 1 plus sin phi 2. Clear? And its direction, this is the direction of current, but this is the direction of current. Last class we have discussed how to find the direction of magnetic field, and there is a point P, this distance is D. So in this case, the direction of magnetic field by using right hand thumb rule, then this is indicate the direction of current, and if you call the finger which indicate the direction of magnetic field. So this is the direction of net magnetic field, which is inward direction and perpendicular to this plane. So this is all about magnitude of magnetic field due to a long state current carrying conductor. Clear? Now we will go for special case. Special case for long state current carrying conductor. Special case. Case 1. For infinite long state current carrying conductor, infinite, and if we increase the length, it is plus infinite to minus infinite, and this point is Q, and this distance is D, and this point is P. Clear? So we have to find due to the infinite long state conductor and current flowing through the conductor I. So we have to find total magnetic field due to this infinite long state conductor. We have, that is B equal to mu naught by 4 pi I by D and sin phi 1 plus sin phi 2. Clear? Phi 1 and phi 2 always measure from this. Clear? If we increase the length, suppose this one is phi 1. If we increase the length, then this phi 1 also increase. Then if we take another point, then also phi 1 increase. Then for infinite length, this phi 1 is turned to be like 90 degree. Clear? Similarly, this angle is phi 2. If we take another point, if we increase the length, then this angle will be increased, and another point, this angle also increase. If we take infinite length, then the phi 2 also increase, which is turned to be 90 degree, and phi 1 which is turned to be 90 degree. Clear? So here for infinite long state conductor, phi 1 equal to 90 degree and phi 2 equal to 90 degree. Clear? So the relation will be B equal to mu naught by 4 pi I by D into sin phi 1. So sin 90 plus sin 90, and the value of sin 90 equal to 1. So you can write B equal to mu naught by 4 pi I by D into 1 plus 1, which is equal to B equal to mu naught by 4 pi I by D, or 112, so 2 I by D. This is magnetic field for infinite long state conductor, and its direction, this is the direction of current, and this is the direction of magnetic field, which is inward direction. This indicates the magnetic field direction which is inward to this plane and perpendicular to this plane. Clear? So this is first special case, and which is important case of this relation or long state conductor. Here, next example or case 2. Case 2. Suppose this is infinite length, and if we, this is infinite minus infinite, and this point is plus infinite. Clear? If this is the final point, this is also another end point. If this end point is coincide with Q, that means this total length we can ignore. Clear? Then this is semi-infinite. Case 2 for semi-infinite conductor. Semi-infinite conductor, that means the total part which is ignored, and there is no another part, that means the infinite point which is coincide point Q. So here this is angle 90 degree. If this is infinite, this is phi 2 equal to 90 degree. If there is the infinite point which is coincide with Q, then this point turn to B, then phi 2 will be 0, because decrease and finally comes to 0. So in this case phi 2 equal to 0 degree. And semi-infinite means one side which is infinite, then phi 1 equal to 90 degree. That means phi 1 equal to 90 degree. As magnetic field due to long straight conductor, that is mu naught by 4 pi I by D general relation. So sin phi 1 plus sin phi 2. Now use the value. Then B equal to mu naught by 4 pi I by D sin phi 1, which is 90 degree, plus sin 0, and the value of sin 0 0, and the value of sin 1 1. So you can write B equal to mu naught by 4 pi I by D, which is the total magnetic field for semi infinite conductor. Clear? So how to find magnetic field for different situation? Now using this relation we can calculate magnetic field for different situation. And in this case, the direction of magnetic field which is inward direction and perpendicular to this board, because this is direction of current and this is the direction of magnetic field. Clear? Next point, next case. Next, case 3. This is long state conductor and this point O and this point P, this distance D. Clear? And in this case, the magnetic field, that is B equal to mu naught by 4 pi I by D sin phi 1 plus sin phi 2, and this is phi 1 and this angle, that is phi 2. Clear? If this point which is situated along the line, if this point P which is lying on the axis or along the length of the conductor, clear? That means magnetic field along the length of the current carrying conductor. So there is a point P where we have to find magnetic field. Clear? And suppose this point is taken to be along the length element, along the line, then we have to find a magnetic field here. So in this case, if this point is lies on the length element or current carrying element, then phi 1 and phi 2. First we have to find the value of phi 1 and phi 2. Here the phi 1, if this point taken to be this coincide with length element, then phi 1 and phi 2 will be 0. So in this case, the value of phi 1 is 0 and the value of phi 2 also 0, because phi 1 and phi 2, the point P which coincide along the length element. So this, if you take this point, then from this is the length element and here theta, this is the direction, this distance is D and this distance is D. So the direction of length element and D is 0 degree. For this distance also the length element and D is 0 degree. So total magnetic field at point P can be write, that is mu naught by 4 pi I by D times phi 1 and phi 2. That means sin 0 degree and next sin 0 degree. The value of sin 0 0 and the value of sin 0 0. So total magnetic field at point P will be 0. This is important relation to remember. Clear? From this relation we conclude that the magnetic field at a point on the length of the conductor or length of the current carrying wire is 0. Clear? If this is one current carrying wire and current I, that is the point Q, where we have to find magnetic field, and this point which is lies on the current carrying element, and this point magnetic field Q equal to 0, because this relation B equal to 0. If you take another point here, point N, this is on the line, so here also magnetic field strength equal to 0. Clear? This is all about how to find magnetic field strength different situation, and this is the first application of Biot Savart law. Clear?